Okay, so I'm going to get this gemstone ready for installing a strain gauge on this top surface. And the strain gauge I'm going to use is this very common 3-element rectangular style rosette. It's our CEA series. This happens to be a 250 URA, which has the advanced sensors technology. Don't need the gauge just yet because I'm going to focus on getting the surface clean. So I'm going to take some of this isopropyl alcohol, we call it GC6. Take a gauze pad like this and just kind of fold it. Put a little bit of the alcohol into the gauze pad and then just wipe off the top surface of this gemstone and just basically clean the whole thing. It's been sitting in a desk, so we just want to clean it up, just like if you were to take your jewelry to a local jewelry store and have them clean your rings and whatever. A lot of times they'll use a little solvent, maybe some alcohol to do that. And that's all that we're doing here is a little bit of alcohol and degreasing it just as the initial step. Now the next part of this is I'm going to create a little bit of surface texture, at least I'm going to try, and I'm going to use a piece of silicon carbide paper, 320 grit. I'll just take it and fold it. And pretty much I'm going to be installing a gauge on this top surface, so I'm just going to take it and see if I can get any little texture added onto that surface. I'll just kind of cross-hatch it a little bit. Again, just trying to dull the texture just a touch. Whenever you're installing strain gauges, you want to have a little bit of surface texture. What that does, it dramatically improves the adhesion, dramatically improves the bite, if you will, of the adhesive to the surface of that part or component. In this case, this gemstone is pretty hard, but you can see I've got a little bit of dullness that's been added. I'm going to take another gauze pad with some alcohol and just wipe that surface off again. Again, all I'm trying to do is create a little bit of texture, to try to promote adhesion. I'm going to take another piece of silicon carbide paper, and I'm going to do that one more time. This time a little bit more aggressive. And then take another gauze pad and just kind of wipe it off. Gauze pad with a little bit of isopropyl alcohol in it. Okay? And then that's about as good as we can do with the silicon carbide paper. So the next step is I'm going to scrub it with a little bit of the Imprep neutralizer. These come in a little blue tip bottle. This is a very mild ammonia-based solution. I'm just going to take a couple of drops, kind of put it up here on the top surface, and then take one of these cotton tip applicators and just kind of scrub that area. I like to put my finger right over the end of it and just give it a good scrub. You know, this thing is already really very, very clean to start with. I'll just give it a good scrub like that. All right, and then take another gauze pad and just fold it and start inside that cleaned area and just kind of wipe one direction and take it and refold it. It's kind of hard to see in the camera, but I got a little bit of surface texture there. So that's what I was aiming for. I want a little bit of that dullness that you see, because that will dramatically improve the adhesion. Now, if this were a real diamond, obviously I couldn't really do that with silicon carbide paper, but this is a much softer gemstone, and I've been able with silicon carbide paper to give it a little bit of texture to promote that adhesion. And you can kind of see that in the camera. All right, the next step is going to be to prep the strain gauge and get it ready for bonding. So what I'm going to do is take the strain gauge. Again, this is a 3-element rosette. It's in the folder. I'm going to take the strain gauge and lay it onto a clean piece of glass. And then take a piece of gauge installation tape. The gauge installation tape we're going to use to cover over the strain gauge, and it gives me a handle to be able to pick the gauge up. So I'm going to take about a 4 or 5 inch long piece of tape, lay it over top of the gauge, and then I'll pick the gauge up just like this. And then now you can see I've got the strain gauge on a piece of tape, and I'm just going to take the gemstone, pick it up, lay the gauge on top of it. The great thing about using a 3-element rosette is that you don't have to orient the gauge in any particular direction. The reason being is that the reference axis of a 3-element rosette ends up being grid number 1, which is that one. If you look very, very closely, and it's probably hard to see in the camera, this one is 1, this one is 2, and this one is 3. So grid 1 is your reference axis, and that's what all your calculations will be based off of. So once I've got the gauge in place on the gemstone about where I want it, I biased it a little bit up because I'm going to have wires eventually running off of the side. I'm ready to lift it and at a shallow angle, and then peel it back just a touch. And at this point, I'm ready to apply the adhesive. But before I do that, and I'm going to use the M-Bond 200. So it comes with 2 components. It's got the M-Bond 200 catalyst and the M-Bond 200 adhesive. I'm going to use the catalyst first. And if you watch, what I'm going to do is I'm going to open the bottle, and I'm going to touch the brush cap on the inside part of the bottle about 8 to 10 times, putting the vast majority of it back in the bottle, just like so. And this is a pretty big strain gauge, but I'm going to try to use as minimal wipes across it as I need just to get it coated. And basically I just did 2. And now you need to wait for a full 60 seconds for it to air dry. So typically what I do is just look at my watch, give it a full 60 seconds. Now the reason that we need to give it 60 seconds is the vast majority of chemical that's inside of this bottle is isopropyl alcohol. Matter of fact, it's about 98%. And basically what you have to do is allow that isopropyl alcohol to evaporate. It's essentially just a carrier for the catalyst. And right there is the word that represents the catalyst. It's too long for me to even attempt to pronounce, but that's what promotes the adhesion, and the curing of the cyanoacrylate adhesive is that chemical. So 98% isopropyl, 2% is the actual catalyst itself, and the isopropyl is just a method to be able to carry the catalyst where you want it to go. Now, where most folks, if they make a mistake with this adhesive, it's usually made with the catalyst, and they think more is better, and actually that's not true. When you think of more is better, what that means, you put it on too heavy, and the isopropyl alcohol takes longer to evaporate. So instead of waiting 60 seconds, you might wait 2 or 3 minutes. I probably wouldn't go longer than 5 minutes, just because of the risk of getting dust and contamination settling on the surface where you're trying to bond the strain gauge. But we've waited our 60 seconds. So I'm going to take that away, peel the tape back just a touch more. And then now we're ready to apply the M-Bond 200 adhesive. This adhesive is a quick setting cyanoacrylate. I just took the cap off. I'm going to squeeze a little bit out of it. And then what I like to do is put a drop, maybe 2 drops of adhesive right at the junction of the tape and the surface that you're going to put the strain gauge on. You take a gauze pad and hold it. Pull the tape up and over. And then take the gauze pad and just wipe it down into place. You take it and you wipe it down into place, and then get your thumb and put your thumb over top of it. And you want to keep your thumb on there a full 60 seconds and try to cover the entire area of the strain gauge. So again, you're back to your timer. You're waiting your full 60 seconds because again, you want to ensure that that gauge gets bonded. So again, watch your timer. I got about another 50 seconds to go. So some folks will say, can you push too hard? You really can't with M-Bond 200, at least it's been my experience that you don't. The great thing about using M-Bond 200 is that basically in just a few minutes, you've got a cured adhesive system that's capable of transferring strain from the surface and into the strain gauge. So what we're going to do is we're going to go 1 minute of thumb pressure, and then we're going to let it sit for 2 minutes. And then basically at that point, we're ready to take the tape off. And at that point, we're ready to inspect it, and then potentially go ahead, assuming it looks good, put the wires on it. So I got a few more seconds here to get to my 1 minute. Feels like since this is a pretty wide strain gauge, I've got a little bit of my thumb that's glued down at the edge. And if you ever find that you're using a cyanoacrylate adhesive to glue down strain gauges and your thumb gets glued down in place, all you have to do is take it and turn it, and it should release just like mine released. And see, here we've got the strain gauge down in place. I still have the tape over top of it. I'm going to let it sit for another 2 minutes, and then we'll be ready to take the tape off and then do an inspection and then put the wires on. Okay, so now we've waited our 2 minutes. We're ready to take the tape off the strain gauge and inspect it. And typically what I like to do is start the tape at one end and then slowly pull it back. And notice how I'm peeling it directly back on itself. I'm trying to minimize the force pulling on top of the strain gauge. And then once you get the tape started, you can go ahead and just peel it on off. And now is a great time for an optical inspection. You know, did you get the strain gauge in the right spot? Is it down nice and flat? And if I take this and kind of turn it at an angle, notice how nice and flat that gauge looks. That gauge is well bonded. It's nice and flat. No signs of a delamination. And you'd be able to see that pretty easily on this little gemstone. But here, everything looks good. So at this point, you're ready to attach wires onto it. You got to be extra careful when you're soldering the strain gauges on non-metallic structures, because there is the risk of damaging the gauge or the adhesive and sometimes the actual structure itself, depending on what it is, in particular if it's a plastic. But here we'll just move very quickly as we go through that. We'll minimize the amount of time where we're dwelling with heat on the tabs of the strain gauge, and we'll get some leads on it so that in theory we could take some measurements. We could put this thing in a press and press down on it and see what happens as we start to put it under some high pressure. You know, how much load can this take? Well, we'd be able to monitor that with the strain gauge. Again, this is a 3-element rosette. It's our 250 URA gauge pattern, which is a 3-element rosette and allows us to solve for principal strains of direction.